Okay, a very good afternoon to all. Today we are going to see digital communication. And digital communication, we are going to see these are the agendas I am going to talk about. Okay, first one is what is communication. Then we are having what are the types of communication. Then components, what are they present in that. Then we are having a block diagram. Then we are going to see about a discrete memoryless channel. Then uncertainty, information, and entropy. Okay. Next, before going to the topic, I want to say what is meant by communication. Can anyone tell me what is meant by communication? Yes, communication is nothing but a sharing of information from one person to another. Either maybe we are talking. Okay, when you are talking, the opposite person will reply for our information. Okay, this is called as communication. Okay, we are having two types of communication. One is analog communication, another one is a digital communication. Okay, analog communication is nothing but a direct information that is continuously changes with the time. Okay, this is called as an analog communication. For example, if we are speaking, is a continuously varying time. Okay, this signal is called as an analog information. Okay, digital information is nothing but the zeros and ones. Okay, this digital information is either maybe we are using a calculators, computers, then mobile phones. All these are processing under the digital information. Okay, these are comes under digital communication. Okay, for communication, what are the components we need? Okay, first is we need a three component. First one is transmitter, second one is channel, another one is a receiver. Okay, what is meant by transmitter? The transmitter is nothing but a information which is processed. Okay, process means if I am speaking means the information will be processed. Okay, this is called as a transmitter. For example, audio, video, computer, it is whatever information we are giving, it will be processed. Okay, processing is nothing but a converting an analog signal into a digital signal, then it will be transmitted in a communication system. That is a communication channel. This channel is nothing but either maybe a free space, wired, wireless or optical medium, whatever may be the medium, it will be a communication channel. Okay, at the end of the system is will be a receiver. The receiver is nothing but receiving the information, either maybe intelligent systems or maybe a decoding system we can use. Okay, in between that we are having a noise. Okay, the noise will be either maybe an unwanted component, it will be accepted by the system. Okay, this noise is nothing but an unwanted component. We won't use this component anywhere, but it will be automatically included in our system. Okay. Next, we are going to see about each and every part of the system. First one is the transmitter. A transmitter is nothing but an electronic component. It will process the signals and it's for a suitable information. Okay. For example, the transmitter will also include a transmission circuit, filters, modulators, mixtures. All these components will be included in the transmitter section. Okay. Next, we are having a communication channel. We already spoke about the communication channel. It will either maybe a free space optical communication or it may be a electrical or electronics medium. Okay. Next one is a receiver. A receiver is also an electronic component. It will convert information into an original form. Okay, whatever information which we are centered in the information in the center side, it will be communicated to the receiver side. These components will be included in the receiver, amplifier, oscillator, mixtures, circuits, and the filters and demodulates. These are the components will be included in the receiver. Okay. Next, we are having a transceiver. The transceiver is nothing but it will include both the transmitter as well as the receiver. Okay. For example, we are using a mobile phone. In that mobile phone, we are having a transmitter as well as a receiver. It will access the transmitter. When you are speaking, it will access the transmitter. When you are receiving a call from some other ones, it will access the receiver. Okay. Telephone systems, fax machine, all these are comes under a transceiver. Okay. Next one, we are having a main important thing is nothing but a attenuation. Attenuation is nothing but a noise. Okay. The noise is nothing but is an unwanted component. It will also degrade a wireless system or wired system. Depending on the distance of transmission, the degradation will be increases. Okay. Next, noise. This is a random noise. What is the difference between attenuation and the noise? Attenuation is nothing but it's an unwanted information also, but it will not be randomly generated. It is generated by the system itself. Okay. Noise is a random information. It is communicated inside the system while we are in a transmission. Okay. Next one is we are having a types of electronic communication, having a simplex, half duplex, and duplex, full duplex. Okay. Simplex, we can simply say that's one-way communication. For example, we can tell that radio, then we are having a TV, then beeper. These are all a one-way communication system. Okay. Next one is a half duplex. It's a two-way communication, but only one person can speak at a time. Okay. For example, we can say that. Walkie-talkie. In police, we are using a walkie-talkie. Then we are having a citizen band, family radio, then armature radio. All these are all examples for half duplex communication. Then we are having a full duplex communication. That is simultaneously the transmitter as well as the receiver can able to speak. Okay. For example, we can sell this telephone, mobile phones. All these are communications that comes under the full duplex communication. Next, we are going to see about these are the main blocks in the digital communication. Okay, first one is the information source. This information source either maybe we can use either maybe audio, video, then data, then multimedia. Multimedia means it will include both audio and video. Okay, all these are we are using in the information. Then analog to digital conversion. Analog information is converted into a digital information. The source encoder. This coded word can be encoded. Okay, encoded is one form of coding is converted into another form. That is called as a encoding. Okay, then it goes to a channel encoder. The channel encoder is, what is the purpose of channel encoder here means converting information into a channel. What medium it will be, okay, it depends upon the application. Channel will be encode information into a channel. Next, we are having a modulation. Modulation is adding a message plus carrier. Okay, this is called as a modulation. This process will be done by a modulator. Then we are having a channel. The channel may be a wired or wireless. Okay, the reverse process will be done at the receiver side. These are all comes under the transmitter side. These are all comes under the receiver side. Okay, this is nothing but a channel side. Okay, the same here we are having a modulator, the demodulator. Here we are having a channel encoder, channel decoder. Then here having a source encoder, source decoder. Here we are having a to D converter. Here we are going to do the reverse process, D to A converter. Finally we are having an information source. Okay. Okay, I already told about the information source, either maybe analog information or digital information. Here the analog information can be generated by a microphone, a speech signal, image, audio, video, etc. All these are comes under the analog data. Then discrete data, we already told about the keyboard, mobile phones, then binary digit hexadecimal numbers, all these are comes under discrete source. Okay, next we are having a to D converter. The A to D converter, which includes the three important components. One is the sampling, another one is the quantization, last one is the coding. Okay, sampling is nothing but we already know about the sampling. Sampling is nothing but testing our data into small samples. Okay, for example, this is my sine waveform. I am going to sample my sine waveform into a smaller parts. Okay, this process is called as a sampling. Converting a time signal into a digital signal. Okay, after sampling, we are going to assign some digital numbers. Okay, depends upon the amplitude. Amplitude depends upon the amplitude. We are going to assign a digital numbers. Okay, this is called as a sampling. Next, we are having a quantizing. Quantizing is depends upon the converting amplitude of the analog signal into a digital signal. That is, for example, I am having a 4, 3, 2, 1. I am going to convert this 4, 3, 2, 1 into a digital values. Okay, that's why it's called as a 1, 0. Sorry, 1, 1, 1. Okay, I am going to convert. Similarly, I am going to convert all the values into a analog values into a digital values. Okay, next we are having a coding, converting a binary code into a final amplitude according to an analog signal. Okay, that's why it's called as a to D converter. Okay, next one we are going for a source encoder. Encoder is nothing but removing the unwanted information. That is, written information is nothing but unwanted information. Okay, next we are having a encoding types. Okay, here we are having two types. One is a lossless data compression and lossy data compression. In lossless data compression means we are going to code every data without missing each and every, which was leaving a single information. We are going to encode the values. That's why it is called as a lossless. Lossy information means we can able to we can remove the unwanted data. Okay, that's why it is called as a lossy data. We can smaller size of data can be removed. Okay, when you are encoding. Okay, this is called as a lossy information. That is lossy encoding. Okay, next one. Next one is channel encoder. Channel encoder is able to detect and correct the errors which are done by the encoder. Next one we are having a modulator. We already told that it is having a message signal plus carrier signal. This carrier signal is always a high frequency signal. Okay, we know about the high frequency signal. It will be used for a long data transmission. Okay, next we are having a demodulator. The demodulator is nothing but a reverse process of a modulator. It will remove the carrier signal and revise the original message. Okay, that's why it is called as a demodulator. Next we are having a channel decoder. Similar process of the channel encoder. It will detect and correct the errors. Then we are having a channel decoder, decode the information. Then we are having a digital to analog information, converting a original information into a analog signal, then having a source sync. Source sync is nothing but whatever data we want by the user, it will convert it into original format, either maybe audio or video format. Okay. Next one, why we are using a digital communication? Okay, we already having a n number of communication system. Why you are specially using this digital communication? Because we are having only zeros and ones. Simply saying only there will be zeros and ones. Okay, these zeros and ones can be easily encoded and cannot be communicated. That is, if you are using a voice means it will be incorporated with the surrounding noise as well as the extra noise will be added when you are using analog. But when you are using a digital communication, we can easily use by using a zeros and ones. It cannot be accompanied with a noise. Okay, having a noise immunity, then having a high bandwidth. Bandwidth can be increased because we are using only a digital data. Okay. Next, we are having a easy transmission. Because we are using a digital means, we can able to communicate with either maybe optical communication or with the wireless communication. It will be easy process. Okay. Next, multiplexing. Multiplexing means we can able simultaneously n number of users able to communicate. Next, we are having encryption. There will be highest security and privacy will be there in the encryptions. Okay. Next, we are having a types of transmission. First one is a baseband transmission. Another one is a broadband transmission. In baseband transmission, we can able to directly unmodified data can be used for a, that is unmodified data can be directly used for a transmission. Okay. For example, while we are using a telephone, we are using a direct voice channel without any compromising data. We can able to communicate with each other. Next one is a broadband channel. That is, we are going to use a high frequency carrier. Okay, high frequency carrier can be modulated by using over the channel. This is by using a radio waves. Okay. The radio waves will be a high information system. Okay. Next, we are going to see about the information theory. Okay. Before starting with the information theory, we have to know about the discrete memoryless tools. This information theory was first coined by Shannon. Okay. Shannon is called as the father of information. Okay. Here we are using a Shannon channel theorem. This channel theorem can be used for a transmission of signals. Just see that. Here is a uncertainty of information. Here we are having a n number of information. For that, probability will be from 0 to 1. The total probability always will be 1. Okay. Next, we are having information. Information is nothing but an amount of information can be given by amount of given information. That is, can be given by a log 2 of 1 by pk. This p is nothing but a probability for k messages. Okay. It can be rewritten as minus log 2 of pk. It is denoted by in the units of bits. Next, we are going to see about the properties. Here we are having a nearly 4 properties. First one, when you are going to give an information, it will be known by the receiver means that one the probability will be uncertain. Okay, that's why if the more uncertain information, if the carrier is more, if the receiver knows the message has been transmitted and the information will be 0. Receiver information when if you know the information whatever we are transmitting, therefore the information amount will be 0. Then we having a total information I1 and I2 and the message will be M1 and I2. Therefore, totally we have to add I1 plus I2. Okay, this is a third property. The fourth one is nothing but M is equal to 2 power n, which will be the amount of information will be carried by n bits. Next one, we are going to see the problems. In the first, we are going to calculate the amount of information. If the probability will be given is 1 by 4. We already know the formula log 2 of 1 by pk. Okay. Whenever we are writing using a calculator, there will be only log value. Okay. For that, converting into a log 2, have to give log of base 10 divided by log of base 10 2. Then only it can be converted into a log value of base 2. Log of 1 by pk can be converted into log 10 of 1 by pk divided by log 2 of 10. Okay. Then only you can able to substitute and find out the values of ik. Similarly, we can given by two probability values, that is the amount of information would be equally likelihood. Equal means it will be either first half will be 0 and second half will be 1. Okay. For that problem, how to use the same formula. Okay. That is log 2 of 1 by pk, but the total information will be added I1 plus I2. Okay. Third problem, we are going to give here they given that PCM will be 0 and with the probability of 1 by 4 and another one is 1 with occurring probability of 3 by 4. Okay, so the probability of 0 will be 1 by 4 and the probability of 1 will be 3 by 4. Okay, for that we are going to calculate. That is log 10 of 1 by P1 divided by log 2 of 10. Then similarly you are going to calculate both the values. Okay, finally you are going to add the values. Okay, this is the fourth problem. We can do it for a similar. A last topic in this is entropy. Entropy is nothing but a total informations. Okay, then P1 is nothing but a probability of information. Then L is nothing but a message which is transmitted. Okay, it is a sequence of message will be transmitted. Okay, for that all the messages will be P1L messages and P2L messages up to M messages we are having. Okay.
Okay, madam. Stop it.
Stop it.